everyone. Today we are going to be looking at section 12, sequences and iterations. So the goal for today is to iterate functions using real and complex numbers. Iteration is a process of composing a function with itself repeatedly. Sometimes your parents will ask you to reiterate what you're saying, and that means say it again but a little bit differently. So it's repeating yourself, repeating, just a little bit differently. And what we're doing is we're using a composition. We've seen compositions earlier this year, the fog and the goth, so hopefully you remember from this year and last, but we're going to go through a couple examples and hopefully they're pretty straightforward for you. Find the first three iterates of each function for the given initial value. X sub 0 here is our initial value. This is what we're plugging in. Iterates are each of the terms in an iteration. So we want to find the first one by taking our initial value of 5 and plugging it into the function 4x minus 3. So 4 times 5 minus 3. So 20 minus 3 gives us 17. For the next iteration, we want to take the previous answer and put it back into the function. There's the composition for you. So 4 times 17 minus 3 gives us 65. And our third iteration, we're plugging 65 in for x. So 4 times 65 minus 3. So 260 minus 3 gives us 257. So those are the first three iterates of the function with the initial value of 5. So pause the video and see if you can do this example. Find the first three iterates of each function for the given initial value. Our function is f of x equals 3x squared minus 4, and our initial value is 2. So let's check your answers. For the first iteration, you plug in 2, the initial value, and you get 8. For the second iteration, we're plugging in our answer for the first iteration in for x. So we get 3 times 8 squared minus 4, so 188. In our third iteration, we're putting our solution from the second iteration in for x. So 3 times 188 squared minus 4, 106,028. So let's take a look at how we would write that with the sequences and series we've been writing now. So it says find the first 4 iterates for each function for the given initial value. So here's a different way to think about it. Instead of writing x and plugging in the previous one each time, we can write that, because we are honors pre-calc students, in terms of the previous answer. A sub n is the answer for the nth term. If I want to plug in the value that I get before, that would be the nth minus 1 term, so that's a sub n minus 1, and that's how it's shown here. So if our x sub 0 is our initial value, that's really a sub 0. So a sub 1 is going to be a sub 1 minus 1 squared minus a sub 1 minus 1, or a sub 0 squared minus a sub 0, which subbing in is 2 squared minus 2. So 4 minus 2 gives us 2. So let's try that again. Our a sub 2 is our a sub 2 minus 1 squared, getting the previous term, minus a sub 2 minus 1. So that's a sub 1 squared minus a sub 1. And when we got for a sub 1 was 2. So 2 squared minus 2. So 4 minus 2 is also 2. Let's try that again. A sub 3 a sub 3 minus 1 is 2 squared minus a sub 3 minus 1 is 2. For our a sub 2 answer, we got 2. 2 squared minus 2, 4 minus 2 is 2. Not every time that you write this in terms of a sub n minus 1 will you get the same answer. It just happens to work out for this equation. So a sub 4 is what our answer for a sub 3 squared minus a sub 3. So 2 squared minus 2 equals 2. We can also use iterations for complex numbers. So here's an example where our function 4z plus the quantity of 3 plus 2i, where our initial value is 1 plus 5i. Here we're adding a complex number, and our start value, our initial value, is a complex number. So the first iteration is when we're plugging in our initial value in for z. So 4 times the quantity and the complex number 1 plus 5i, and then I want to add the complex number 3 plus 2i to that. So distribute 4 plus 20i plus 3 plus 2i. Add your like terms together. So here we get 7 plus 22i. Find your second iteration. 4, take the previous solution, plugging it in for z, 7 plus 22i plus 3 plus 2i. So 4 times 7 is 28 plus 88i plus 3 plus 21, or plus 2i gives us 31 plus 90i. And find our third iteration. 4 times the quantity of 31 plus 90i plus 3 plus 2i. So we get 124 plus 360i plus 3 plus 2i gives us 127 plus 362i. So those are the first 3 iterates of the function f of z equals 4z plus 3 plus 2i, where our initial value is 1 plus 5i. So if you've got any questions, please fill out the Google form on the right of your Haiku page, and we will see you guys tomorrow.